Hi guys, today we're going to have a look at gradients of intervals and lines. So an interval is just a part of a line, while a line is, an extension that we put arrows on, which is what you're used to doing in the junior school. Okay, so the first thing we're going to have a look at is the formula for a gradient. There's a couple of new ones that you're going to learn today. The gradient formulas are as follows. The first one is rise over run. Gradient equals rise over run. You have seen that one many, many times. The other one is a gradient between 2 points. So if the gradient of the line between these 2 points, x1, y1, and x2, y2, is given by m, remembering m is the letter that stands for gradient. It's not g. G is gravity in maths and science. We use m for gradient. So when we've got 2 points given to us, it's still our rise over our run. Remembering our rise is our height, or how high up it goes, and that's our y values. So the rise, I'm still looking at y for rise. I'm still looking at dividing by the run, which is our x, or how far along it goes. But when we've got 2 points, we're just going to subtract those 2 points. So we're going to take our y value minus our other y value divided by our x value divided by our other x value. It doesn't actually really matter which pairs of points you choose as x1 and y1, as long as the two that are at the start of the formula are the pair that go together. And I'll show you that below when we have a look at the example. Okay, so let's use that. Example says, find the gradient of the line between the points 3, 5 and minus 1, 2. So remember, gradient is m, gradient is slope, it's rise over run, but we're given 2 points. We're still doing rise over run. We're just finding the rise and the run slightly different. We're going to do it as y2 minus y1, x2 minus x1. Let's call this first point x1 and y1, and then we'll call this second point x2 and y2. So we're just going to put that into our formula. So to start with, we're going to go 2, take away 5. Okay, so we've got one y from one point, the other y from the other point. So it's just seeing how far apart those 2 points are. That gives us our rise. And our run takes that corresponding points to the y. So we had our y first, that was 2. So the point that went with that was the x2 that was minus 1. So make sure you're picking that one for your first one. x2 minus x1. Let's see what we've got. 2 minus 5 is minus 3. And minus 1 minus 3 is minus 4. Those two minuses give us a plus, so we've got a gradient of 3/4. Okay, let's go down a little bit further. The gradient and the angle of inclination. You may or may not have seen this before, but we can actually think of our slope or our gradient of the line in terms of an angle. So let's have a look at this little axis here just before we get into it. X, Y. Before we had the points 3, 5 and minus 1, 2. So I'll plot those on there. So here are the points from the previous question. There was our slope. It was going in the positive direction, but our slope was 3/4. Or our gradient was 3/4. But what we can actually think of as well is that our slope or our line is how far up our line's moved from here, being the x-axis, up to here. It's an angle, and it's called, we generally just refer to it as theta. So we can think of our slope as an angle. And when you're out working in the real world in jobs, say you're building a set of stairs, or you're looking at how steep a roof is in terms of degrees, you're going to find that it's going to be an angle. It's not very often going to be a gradient. You might see a 3 out of 4, but a lot of the time the theta gives us a practical solution or a real world example for our gradient. So let's have a look at this. The gradient of a straight line is given by m is equal to tan theta, where theta is the angle that the line makes with the x-axis in the positive direction. So it's kind of like back into trigonometry topic, where we were looking at our all stations descent, and we're just seeing how far that line's moved up in the positive direction. So it's going to be how far that it moves up when we're moving anti-clockwise. So let's have a look at the question. Example. Find the gradient of the line that makes an angle of 45 degrees with the x-axis in the positive direction. So theta equals 45 degrees. Our formula for gradient is m is tan theta. Remember, m is our gradient. We've got theta, so m is tan 45 degrees. You can pop that straight into your calculator, or you could use exact value triangles. but the calculator will work nicely with that. The gradient is 1. So a line with a gradient of 1, there's very many options that we could have here, but one of them might be that it's the line y equals x. That could be one of them. But any line that would have y equals, of the form y equals mx plus b, where our m is 1, so y equals x plus b. It could also be the line y equals x that went through some other point b up there. Or it could be another line that's parallel to it that went through the point minus b. So it's any line of that form, and all of them are making an angle of 45 degrees. Okay, let's have a look at the quick quiz number 5. Number 1, to sketch the line y equals 1/3 x plus 2. There's a few ways that we could do this one. We know straight up that it's going to cut the y-axis at 2, because that's our y-intercept. So it's going to go through there. It's going to go in this direction, because that's a positive slope. The other direction is a negative slope. So we've got a positive because it's 1/3, so that's the direction it's going to go. And we can think of it a couple of ways. We could look where it cuts the y-axis. So it cuts the y-axis at x equals 0, so we've got that. We can see where it cuts the x-axis at y equals 0, and we can play around with that. However, we could also look at, well, here's our point that we know is on the line. Our gradient is 1/3, and that is rise over run. So for each 1 up, which is our rise, we're going to go 3 across. So 1 up and 1, 2, 3 across. So there's a point that would also be on our line. So based on our y-intercept and finding the gradient, we're going 1 up and 3 across. I've got 2 points, so that's actually enough to draw that graph. But if you didn't want to do it that way, you could still work out where it cuts the x-axis, because we've got where it cuts the y-axis. So it cuts the x-axis at y equals 0. So I'll put y to 0. I get 1/3 x plus 2. Let's rearrange. We'll take 2 from both sides. So we get minus 2 equals 1/3 x. Or you can write that, if you don't like it, as 1/3 x. You just write it as x over 3. That looks a little bit neater. Let's times both sides by 3. I get minus 6 is equal to x. So that's the point minus 6, 0. That's where it cuts the x-axis as well. That's over there. So I've got 3 different points now, and there's 2 different ways that I can find it. So there's my line. This might look a bit neater than mine, but it goes through there. That's the sketch of that graph. Okay, let's have a look at the next one. Find the value for number 2 of the y-intercept and x-intercept for 3x minus 6y minus 2 equals 0. So remembering the y-intercept happens at x equals 0. So we'll pop that into our equation. We get 3 times 0 is 0, minus 6y minus 2 equals 0. We're going to add 2 to both sides. We get minus 6y equals 2. We're going to divide both sides by minus 6. And I'm going to end up with y is 2 divided by minus 6, which is minus 1/3. So that's my gradient. Sorry, that's not my gradient. I apologize. That's the value of the y-intercept. So when x equals 0, that's where it cuts the y-axis. I'll pop a little highlight on there so you can see. So at x equals 0, y equals minus 1/3. And let's find the x-intercept. The x-intercept happens when y equals 0. So we'll just put that in there. X-intercept happens at y equals 0. We'll try and squish it in. So we'll get 3x minus 6 times 0, which is 0. So I'm going to miss that middle term there because it's got a 0 now. And I've got minus 2 still, equal to 0. Let's rearrange it. We'll add 2 and add 2. I'm going to just cut it here and go up here. 3x is equal to 2. These guys cancel out. Divide by 3. X is equal to 2/3. So that is our x-intercept. And that happened at y equals 0. So there are intercepts for that equation or that line. Okay, next one. State the gradient for number 3 here. State the gradient and the y-intercept for 3x plus y equals 8. Now, when it's in that form, we can't state anything we need to get it into the form y equals mx plus b in order to do so. And then when we're in that form, we can straight off read the m for gradient and b for y-intercept. So let's rearrange it. We're going to take 3x from the left. We're going to take 3x from the right. And what we're going to end up with, I'll pop it over here, is y equals minus 3x plus 8. We can now read off that m is equal to minus 3. And our y-intercept is equal to 8. That's nice and easy, that one. Okay, part 4. The line, the gradient of the line joining 3 minus 2 and 4, 5. So remember, y is, not y, sorry, I'm having a bad day here with my explanations, aren't I? Not y, but m. M is our gradient and m is our rise over our run. If we have sets of points, it's the change in our y values. It's still the rise. And our change in our x values, which is still the run. So I'm going to call this first 2 points the number 1 points. And the second 2 points the number 2 points. It doesn't matter. If you were to switch them around, you will still get the same answer anyway. It doesn't matter which way you do it. So the change in the y, we're going to have 5 minus 2. Okay, so just be careful. There's a negative there, and we're taking away that negative, so it's a double negative. And 4, take away 3. So 4 take away minus 2 is 4 plus 2, which is 7. And the bottom line is 4 minus 3, which is 1. So our gradient is 7. It's very steep. Okay, last one. Find the gradient of a line which makes an angle of 60 degrees in the second quadrant. Let's draw that first. So an angle of 60 degrees in the second quadrant. This one's a little bit, probably not explained well. I'm taking it that it's making an angle of 60 degrees in here. Okay? That's what we're going to assume that it's doing. However, when we think the explanation of theta, when we're working out our gradient in terms of angles, is this way. So we want to think about what that theta is. What's that theta going to be? Well, the whole angle there is 180. We've already got 60. So what have we got left? We've got 180. We've taken off 60. So this theta here is equal to 120 degrees. So we need to figure out what our angle is going to be. Sorry, not an angle, our gradient with our angle. So m is tan theta. M is tan 120 degrees. So you can straight away pop tan of 120 degrees in your calculator, and what you're going to end up with, and we'll do this to 2 decimal places, is m is minus 1.73. That's to 2 decimal places. Now, that makes sense if you have a look at our line over here. It's sloping in the negative direction. But also, if you think back to our trig topic, all stations to central, we're looking at tan of an angle, and tan in that second quadrant is negative. And we've got a negative value, which is what we want. So that's also showing that our topics are really starting to overlap here.